This is a video all about Unit 1. And so first off is the intro to maps. So the main types of maps are reference maps, thematic maps, maps used for depicting quantitative values, and cartograms. And so the different type of data found in the maps. So in a reference map, you can find informational data, physical and data about physical and man-made features. An example would be a theme park map. You can look at the theme park map and see the exact layout and stuff. Thematic maps can show story and quantitative data, which is like density and distribution, and gives you a visual stimuli. And how they use geospatial data in the maps, they can use choropleth, which is color or shading, dots, which show value and location, and graduated symbols that symbolize size of value to data, isoline, which connects the area with lines, cartograms that distort the appearance of places show value, and other different types of data in maps is when measuring data, they use relative, or qualitative, or absolute quantitative data and location. Patterns and processes. Says geographers ask why a pattern is the way and describe how things is, like if it's clustered, it's in a group, nucleated, clumped, concentrated, dispersed, uniform, random. Also in this section, there's a couple of different types of projections. A projection is a 2D flat scale model, and it can have distorted shapes based on the model. It shows distance, shows relative size, and may show physical features and elevation. So the first projection is the Mercator projection, which is a flat square and has very little distortion, and it has consistent direction. It's a rectangular map, and the size is distorted toward the poles, which makes the high latitude look much larger. And there's also the Robinson projection, which is useful across oceans because it focuses more on oceans. But disadvantage is that it makes the space for oceans by using space for oceans, it makes the land area smaller. And there's also the Gauss-Peter projection, which preserves size but distorts shape, and it's basically the opposite of the Mercator. And then the Goods, which removes much of the ocean to keep landmass shapes. It's also like a thematic. And there's geographic data, which is different data identified in maps. For example, the government may use a census, which tells quantitative data, and it allows them to see density, statistics about jobs, how much money is made, and overall more data about people. And so geographers is another thing. So they study why and where, and governments. The next part of this is about geographers, and they study where and why, and things that they use to technology they use is the Global Positioning System, GPS, which is satellite used for navigation, which provides you precise location in relation to surrounding areas and your destination, and has remote sensing, and satellite orbits the Earth and sends data back to Earth. And there's also the Geographic Information System, which is the GIS, which is a computer system that stores information about locations and layers, and there will be a visual example that you can look at. And it includes imagery, elevation, transportation, address, boundaries, water features, survey control, and more specific data. Then we have the power of geographical data, and I would just use this map because it's an easy way to explain it. So there's a German federal map example which should be shown, and basically based off of the map and the chart, you can see the spatial pattern in it, which allows you to see the rate of unemployment, and it can show how it's decreasing from north to south as it varies. And East Germany has the highest rate of unemployment, and the southern region has the lowest. And this is just a quick, easy example, just to kind of give you an idea of how the power of. We have also spatial concepts, which kind of relates to the previous one, and it's based off of spatial patterns of scale, and conclusions can be made on a region's characteristics, and it can explain why regions have distinctive features. Geographers can identify cultural, economic, and environmental factors that display spatial patterns, and they can used find data on an area using a geography of an area, and it can put that data and gives local information. And the spatial patterns just allow geographers to look more in depth into things, and there would be a map example, but I don't have time for that. Environmental interactions. So let's say we're going to try to talk really quick. So there's talks a lot about sustainability and other things. So when you talk about sustainability, they're talking about renewable resources, things that are quickly reducing nature, and if on a limited supply and resources like solar, wind, energy, and other stuff. And you also have non-renewable resources, which are slowly produced in nature, and humans can run out of it, which is like petroleum, natural gas, and coal. And make sure to not run out of these resources. We depend on, so humans incorporate sustainability, which includes recycling, decreasing pollution, planting trees, and the United Nations have created or identified three pillars of sustainability, including the environmental conservation efforts are crucial to monitoring resource depletion and the economy. Natural resources are collected and sold for money. The market and supply demand affects resource depletions, and the society, which is what the majority of humans are consumers, with humans being more environmentally conscious and decreasing their carbon footprint. They are practicing sustainable theories related to this. There's environmental determinism, which is, just to put it simply, based off of where you are, or geography decides everything, and that's basically it. That's just a very simple definition. Possibilitism, another very simple definition, is just that the physical environment may put a little handicap, but through technology and human actions, we can overcome the physical environment in a way. There's four abiotic systems that we interact with. There's the hydrosphere, which is all the water; the lithosphere, which is the Earth's crust and upper mantle; biosphere, all the living organisms on Earth; atmosphere, which is the layer of gas surrounding the Earth. And we've used these abiotic systems and have used them to support ourselves, and this is the way how we use them. So the hydrosphere provides all the water that we humans and organisms need, and the lithosphere, which is most plants and animals live in, and is how they obtain food and shelter. The atmosphere provides oxygen and protects us against the sun, and the biosphere, which is interrelated environment, and consume and depend on the byproducts from the animal. Scales of analysis, which I'm talking about fast. The scales of analysis is how a map is analyzed and can rely on statistical data. The scale shows the relationship between the portion of the Earth and the being studied as a whole. An example would be a color-coded map is off of religion, and you can use this to take the census, which is a very important piece of data that is used by the geographers, and maps can utilize things like color to show relation density and stuff like that. So there's different types of scales. There's the global scale, which is exactly what it sounds. It's the scale of the world, and it's in a global scale setting. And the regional scale, which is just the interactions occurring within a region in a regional setting. A national, which is a view across the whole country, just at a nation scale, and a spatial scale, which is basically what you would say a community scale. And these scales are relevant in maps because, as you can see based on the scales, it gives you data about different scales. So I was saying on a global scale or national scale, it can give you more specific or broad information. So the like the quantitative data can vary depending upon, like, say, national average income can be much higher or much lower than if you were to go to a very more specific scale of maybe a certain region. Could change fast. Regional analysis, and this can help us with understanding the similarities and differences relative to the relationships between people and places, and is included with the concept of regions and functional and formal regions. So lastly, this is regional analysis, and this helps us with understanding the similarity and differences relative to the relationships between people and places, and is included with the concept of region, or functional and formal regions. So starting off the different types of regions, there's the formal region, where it's an area where everyone shares one unique characteristic, and like a characteristic can be like a common language, a climate, political party, and the hub of this. Then there's the functional region, which is the area organized around a hub, and the hub can be the center of the city that attracts people. Like downtown is the hub of most cities, and like T stations have a main hub where all the signals are emitted, and then there's a different vernacular region, which is an area that emerges from a sense of place. People believe in the area and exists because of culture, so this is not exactly a physical area. And it's like how people have different definitions of something, like say like the South, and which states are included with the South. And so it's and these regions are all defined based on off of unifying characteristics in a place's activity patterns. Those regional boundaries, where features and characteristics can change, and regional boundaries are traditional, transitional, and often overlapping and contested, and they can be applied on a local, national, and global scale.